Carbon has many possibilities as forming structures. It could form straight chains, branched, and also rings. For example, if I give you example of a pentane, it's 5 carbons and it can form a structure like this. Now I'm going to saturate them with hydrogens. I'm going to show all the single bonds, sigma bonds with hydrogens. So this is an example of a straight chain carbon family or molecule of pentane. Now what else it can form? It can also form a branch version of isomer of pentane, for example. So I could have 4 carbons and the last one to be on a carbon such as this. And then I put all my hydrogens. And then if you calculate number of hydrogens in both examples, you will see you have exactly 12. So it is an isomer of pentane. The names, we get to it gradually, but this is to show there is possibility to have a branch. This is 2-methyl butane. Also, it can produce rings, and the only ring we really want you to know and concentrate on is example of a benzene, which is C6H6, and it has 6 carbons in a ring-like structure, and there is a double bond, single bond, double bond, single, double, and then each carbon has 1 hydrogen attached to it. So this is an example of a ring structure. And since there is possibility of resonance, these double bonds really travel. This is what we prefer you to show it as resonance structure. A hexagon like this with a circle in between to represent the skeletal picture of a benzene. Also, one of the things you should know as fundamental, so I go after it, is carbon can form single bond to carbon, double bond, or maximum triple bond. You could have carbon-carbon single bonds. For example, a case of ethane. Now, if you are a single-single, you should also be able to use your data booklet and look at the bond length between carbon and carbon, for example, is 0.154 nanometers, the longest. And if you look at the enthalpy or the bond strength, it's 348, the weakest. It could form a double bond, which now the carbon-carbon gets closer to each other and also gets stronger. So example of ethene. It could also form a triple bond. This is the shortest and the strongest. I'm going to draw this one more time. So triple bond. Now triple bond, if you look at the bond length in nanometers, is 0.129, the smallest. If you look at double bond, is 0.134. If you look at single, is 0.154. You should also look at their enthalpies and realize the strongest means the triple bond and the shortest means triple bond. Benzene, on the other hand, is somewhere between a single and double, both in terms of distance or nanometers, and also both in terms of bond strength, because of delocalization or resonancy. Few other fundamentals I want you to know before we get into real organic chemistry. There are a bunch of formulas that you need to realize and recognize. One is molecular formula, which is the exact number. For example, I go after butane. Butane is C4H twice as much plus 2 more, which is 10. So this is butane, and its molecular formula shows exact number of atoms within the molecule. Now if you simplify it into whole numbers, so 4 and 10 are both divisible to 2, so it's C2H5. You have produced empirical formula, which is the simplest whole number ratio. You cannot show it as C1H2.5. They have to be whole numbers. So this is the simplest, which is empirical formula. The structural formula, you will show the minimum possible details getting the structure across. So for example, butane could be CH3, CH2, CH2, CH3. But it also has another possibility, another isomer. So that could be shown as CH3, CH2, CH. Now CH3 I put in parentheses, attached to CH, and I end it with CH3. So these are two possible structural formula for butane. This is normal butane. And if you look at the slide before that I did a few seconds ago, this is 2-methyl, look like 2-methyl pentane I did, and this time it's propane. Now there is also displayed formula that really gives you the picture of all the bonds, attachments, and their placement. So in this case we have 4 carbons, and then you put single bonds. Each carbon should have 4, and then you put your hydrogen. So this is displayed formula for normal butane. And if I want to show 2-methyl propane, I do the same thing. The longest chain is 3 carbon. On the second carbon is another attachment, another methyl. So this is the displayed for 2-methyl propane. So these are possibilities. Now this is just to reinforce that there is molecular formula, which is all the atoms involved. Empirical just shows the simplest ratio of those. Structural, it could can be in this form or also condensed form. If you don't mind normal butane, I'm also going to show it as CH3, and I can combine my CH2s. I have 2 of them. So I open a parenthesis, CH2, close the parenthesis, say I have 2 of them, and end it with a CH3.